Hello and welcome to this SimScale video tutorial where I will be showing you how to run a flow analysis inside an irrigation system. Let's first import our model by just drag and dropping our file into the platform and click upload. Once our model has been uploaded, we can actually see it in the display window and interact with it by changing its orientation, the render mode, and also create topological entity sets. Let's start by create a simulation, which is in our case an incompressible one. I'm first going to start by creating a topological entity set representing the walls of our geometry, and this will help us creating different boundary conditions and help us with the meshing of our domain. Let's select all the surfaces and unselect by clicking on the outlet of our system as well as in the inlet, and let's name our new set. We can also create a set for the inlet and a set for the outlet similarly. Let's create our mesh by clicking on the unit here and select the new mesh preview and assign the fineness to 4 and a hex element core option and 32 type of processor. Click save. We're going to apply one single type of refinement called the inflate boundary layer to the walls of our system and keep the settings to default. Let's generate our mesh. So while our mesh is being generated, we can already assign material to our system. In our case, we're just defining water as our main fluid and click apply. Standard parameters for the kinematic viscosity and the density are populated. We can click save. For our boundary condition, let's click velocity inlet and assign a fixed value for the velocity to minus 0.5 meters per second at the inlet, and we can use the previously created topological entity set and click save. For the outlet, we're going to assign a pressure outlet boundary condition at 0 gauge pressure. Let's click our outlet and click save. We can also indicate some result controls for our simulation, which will help us monitor the performance and the output result in a quantitative way. To do this, we can monitor the inlet and outlet flow rate by simply clicking the surface data area integral for our inlet and outlet phases. We can also monitor the average velocity in a similar way by just clicking data average and clicking inlet and outlet. Our mesh has now finished being generated, as you can see, within 3 minutes. We're now ready to start our run by clicking simulation runs plus button here. We have an error showing that we haven't assigned all the faces to a boundary condition, but in this case a no slip wall boundary condition will be assumed for any of the faces we haven't assigned to a boundary condition. Click start. So our first run is finished in 22 minutes and we can post-process the results by clicking on the solution fields item on the tree of our simulation run. We can find again the model we've imported and create some cutting planes through it in order to assess different scalars. So I'm going to create a plane in the X direction and invert the direction of that plane, and I'm going to visualize the velocity of the inside of this piping system. We can also rotate and zoom and interact with the model by clicking the select element button and interrogate the mesh at any location we want. We can also change the type of scalar we're going to visualize, and changing this to pressure, for instance, and we can also interrogate this model here in different location. One other thing we can do with the result would be to generate a particle trace. By this, you click particle trace plus button and select the seed face. We can generate this visual of transparent surface outline, and clicking the inlet of our system, and this would generate different streamlines in our system. We can color these streamlines by any other scalars, but in our case we're going to choose the velocity, and you can see how this develops throughout the piping system. We can create an animation by clicking plus and using the particle trace state, and this will give us an idea of how the fluid propagates throughout the system. If you want to save one of these visuals, you can click on the screenshot button by clicking plus here, and this kind of visual will be saved, and you can of course download any of these screenshots. So I can easily go back, hide this particle trace, but go back to my cutting plane and, for example, save these as a screenshot.